Hi, Honors Algebra 1. We're going to be reviewing 2.6 and 2.7 today, so let's go ahead and dive right in. Hopefully you already have your notebook and something to write with. Before we can do that, we really should spend a little more time talking about 2.3 and 2.4 just to make sure we're really solid on those topics. Solving equations is so important, and we also need to utilize these skills for today's lesson. So let's go ahead and do these examples. So feel free to pause the video if you need to copy these down. You may want to just write them down as I do it, just so you are leaving enough space to do each problem and not running out of space or leaving too much space. So maybe just do them one at a time. So I'm going to start with this example on the left. So I've got some terms that I have to combine first. I don't see parentheses, so no need to distribute. I'm going to combine my two variable terms and get 7m. And at this point, it just looks like a two-step, so I'm going to solve it. I have to add the 23 first. I got to take care of what's not touching before I can take care of what is. I get 28. And now I can just divide both sides by 7. 7 goes into 28 4 times evenly, so 4 equals m is my final answer. All right, now let's take a look at the next problem. So if I see just parentheses, I need to distribute. So I'm going to do that first and get negative 16x plus 8. The two negatives should give you a positive. And again, it's a two-step. So I'm going to solve by subtracting 8 to both sides first. I get negative 16x equals 28. And then I'm going to divide both sides by negative 16. Now 16 won't go into 28 evenly. Just because I started off with integers doesn't mean my answer is going to be an integer. Remember, all types of numbers are fair game here, whether they be fractions or decimals. Instead of going through all the hassle of doing long division and making this a decimal, I'm just going to leave it as a fraction and just reduce it as much as possible. So when I look at 28 and 16, I know right off the bat that they're divisible by 4. I don't know right off the bat if that's going to reduce it all the way, but let's start with dividing it by 4 and see what we get. My numerator is going to turn into a 7. My denominator is going to turn into a 4. And don't forget that there's a negative here. 7/4 actually does not reduce any further, so there's my final answer. Now let's take a look at the third example. This is variables on both sides, so I don't have parentheses, don't have like terms, so I'm just going to collect all my variables to one side by adding or subtracting. Again, it doesn't matter which term you move, so you make the choice for what you think is easiest. I personally am going to subtract the 2x because I know that's going to leave me with a positive 3x term, and I like to deal with positives more than I like to deal with negatives. Now I have an easy two-step. Undo the addition subtraction step first. Undo the multiplication division step last. Again, I'm getting a fraction. I could try and divide and make it a decimal, but you'll end up running into a repeating decimal here. And just a quick comment about rounding answers. If it doesn't say in the instructions on an assignment that you're allowed to round to a specific place, you can't just make that assumption and arbitrarily round to the 10th place or the 100th place, because then you're actually affecting the accuracy of your answer. So don't round unless you've been specifically told to round. Always give an exact answer. Only round when you're told to. So I'm going to leave it as a fraction because that's my exact answer. Okay, and then the next example, I have to distribute first because I see parentheses. I'm going to attempt to get my variables on the same side since I don't have any like terms. When I do that, the x term is going to cancel out on both sides of my equation, leaving me with 12 equals 12, which is a true statement. Now, if you recall from last time, there's different ways that you can write your answer here. So long as you give one of the appropriate phrases, then you're fine. But I can't just stop here. I have to write one of those phrases. So I'm going to say all real numbers, and that phrase is my final answer. All right, last example here on this slide, I'm going to combine some like terms, so that's on the right. That's gonna give me a positive 9m. I'm gonna bring down my plus 5, And now I'm going to attempt to get my variables on the same side. But again, when I do this, they're going to cancel on the right and they're going to cancel on the left. That's going to leave me with -4 equals 5, which is a false statement. When this happens, you must write as your final answer, no solution. If you don't have this phrase, you're not going to get full credit because you're not going to be completely done. So just a bit of review. Make sure that you've got all of this in your notebook before we move on, and I'm going to give you some to try on your own. Okay, so let me just erase my board real quick. Go ahead and try these on your own. Now, the one that might be more problematic for you is the one with the fractions, but remember, you learned how to clear fractions in the last section, so utilize whatever strategy is easiest for you. I will pause the video, and when I unpause, you'll see solutions on the board. Okay, so here are the answers that I am getting for both of these. So again, the one that was on the left with the fractions was probably the one that took you the longest. I used the clearing the fractions method. You didn't have to use that technique, but if you did, this is what your solution would look like. Regardless if you cleared the fractions or not, you should have gotten a final answer of x equals -7/2. Just as a quick review of that method, what you're going to need to do is first, if you see any parentheses, you have to distribute before clearing any fractions, okay? What I did for the first product is I did that off to the side. The 3x didn't look like a fraction, so I put it over 1. You can do that with any value that is not a fraction. You can always put it over 1 to make it look like a fraction. When I did that, I noticed that the 3's would end up cross-canceling, leaving me with just a -10x over 1. Anything over 1 is just going to be an integer, which is why I left it -10x. And then my second product should have been positive because the 2 negatives canceled. Then to clear the fractions, you look at all the denominators in the equation and find their LCD. Here I just had the one denominator of 9, so 9 was my LCD. You multiply that LCD to all terms in the equations, regardless if they're fractions or not. So I had to multiply with the -10x as well. And then at this point, it's just a normal two-step with integers. So as I'm solving here, I get to this step where I divide both sides by -90. And again, I could sit there and try and do long division and see what that might get me. But when I'm looking at this, I'm actually going to reduce it because I think it's easier to reduce things as fractions rather than do long division. And when I look at these numbers, I notice they end in a 5 and a 0. All numbers that end in 5 or 0 are divisible by 5. So I set up my long division for the numerator and denominator and got 63 and 18. Careful when you're doing this not to drop that negative. And then when I look at 63 over 18, I can reduce that in my head both by 9. So I get 7/2 and it's negative. On the right-hand side, I just distributed the negative into the second group, combined my like terms, and when I did that, the variable terms ended up canceling, leaving me with a true statement. So my answer is all real numbers or infinitely many solutions or identity. Let's take a look at the next group of problems. Again, I'm going to erase my board so you can give these a try. And I'm going to pause it once more, and then when you unpause this video, I should have solutions, on the board. Okay, so here are the solutions that I ended up getting for both of these. So for the decimal equation, I chose to clear the decimals. Again, you don't have to use that method, but it actually works out quite beautifully here. So to figure out what power of 10 that you need, again, just find the decimal that has the furthest right decimal place. Here they all end in the same number of digits. They all have a tenths place, so that's the power of 10 that I want to use is 10. It's quite easy to multiply everything with that power. Just take the decimal point, move it however many places to the right as you have zeros. There's 1 0 in the number 10, so move them all one place to the right. And then at that point, I just attempted to collect all my variables to one side. In this particular example, I actually decided to add the term that was on the left over to the right, so that way it would leave me with a positive. And then I just solved the two-step from there. When I got down to this division step, again, you can do long division to try and get your answer. I personally like to see if I can reduce it as a fraction as much as possible when the numbers are nice and small like this. I looked at 28 and 20, immediately noticed they were multiples of 4, reduced it to 7/5. If you did use long division, you should have gotten 1.4 as your answer. So just because you're starting off with decimals doesn't mean you have to give me the answer as a decimal. 7/5 is a perfectly valid answer. The one that's on the right, I distribute. I go to get my variables on the same side. They ended up both canceling, and I got a false statement, so my final answer has to be no solution. Okay, so now that we've kind of reviewed solving equations, let's actually get into the real meat and potatoes of the lesson, which is all about rates, ratios, and proportions, and more importantly, how to solve a proportion. So a ratio, you may want to write down in your notes a quick definition. A ratio is a comparison of two or more quantities. There's 3 ways that you can write a ratio. You can write it as words. So let's say I'm comparing A to B. I could write A to B. You could write a ratio with a colon. So I could say A to B like that. Or you can write it as a fraction, A over B. So a fraction is a ratio. It's a comparison of 2 quantities, okay? Now let's talk about what a rate is. In a rate, you still are looking at a ratio, but your numerator and denominator have 2 different units. So I might actually write that, ratio with different units. So for example, you might have, I don't know, $750 every 3 days. That would be an example of a rate. You've got money as your numerator unit and days as your denominator unit. Other common rates, money per hour, miles per hour, basically anything that's a ratio where the units on the top and bottom are different. That would be a rate. A unit rate is a rate with a denominator of 1. So rate with denominator of 1. To get a unit rate, you divide. Okay, so you may just want to add that in your notes. You divide to make a unit rate. So for example, if I wanted the unit rate for $750 over 3 days, and I wanted my denominator to be a 1, so I wanted it per 1 day, I would just divide. So let's see. Does that actually go into it evenly? I think it does. So 3 goes into 7 2 times with 1 left over. That would make that a 15. So 250 over 1 day. That example worked out quite nicely. So all you do is you divide to make your unit rate. So long as it's a rate with a denominator of 1, it's a unit rate. And then a proportion, which is what we're going to be solving next, that's when you have 2 ratios that are actually equal. 2 ratios that are equal. So it's an equation that says 2 ratios are equal. Whoops. So you'll have some sort of ratio, and it'll be set equal to another ratio. And to solve a proportion, you would cross multiply and set those cross products equal to each other. So you would have A times D equals B times C. And that's actually the strategy that we're going to use for the remainder of this lesson. We're going to look at a proportion and we're going to use cross products to solve them. Some teachers refer to that as the butterfly. So take a moment to copy these proportions in your notes and we'll solve them together. Okay, so for the first one, I'm going to take the -3 and diagonally multiply it with the 5. That's going to give me -15. And then I'm going to cross multiply the 4 with the x and get a 4x. Now it doesn't matter which side of my equation I put my cross products on. I could have started with the 4 and the x and put that on the left and put the negative 15 on the right. So long as you're setting your cross products equal and doing all of your arithmetic correctly, you should get the same answer. So now it's a one step. I can just solve this. If I divide both sides by 4, I can either do long division and make it a decimal, or again, I could just look at this as a fraction and say negative 15 fourths, that's not going to reduce, so I'm just going to leave it as negative 15 fourths. There's no need to go through and make it a decimal. I can just leave it as a fraction if I want. Okay, let's take a look at the next one. Immediately, you can probably already tell it's more complicated because I've got a number in front of my x here, and I also have x's in more than one place. And this x has a minus 3 on the end. Let's start with the one that looks a little less complicated. If I just multiply, here, let's do that again. If I just multiply this 2x and 4, that's going to give me 8x. Now to do the other cross product, anytime that you see a part of your proportion that has an x or variable and then a plus or minus, the number that you multiply with that sum or difference, it's got to be sitting outside of a set of parentheses, and that sum or difference goes inside. You have to set it up with the parentheses. The parentheses are required. I may even change this color here just to really bring your attention to this. You really have to have the parentheses. If you don't, you're going to do the problem wrong. Because you're not just multiplying the 11 with the x, and you're not just multiplying the 11 with the negative 3. You're multiplying it with the entire quantity, so you're actually going to have to use the distributive property and multiply the 11 to both of the terms. Now I also have variables on both sides. Now I typically like to move the variable in such a way that I get a positive term, but if you notice, I only have the one variable term over here. So if I move the 11x over to the left, I'll have a negative, but it'll create a one-step equation. So I actually am going to go for the negative term this time. You could have moved the 8x to the right, but you'll just have to remember that if you subtract 8x to both sides, you're going to have a 0 that's left on the left-hand side. And if I subtract here, that's going to give me a negative 3 is equal to a negative 33. Don't forget that minus sign does count as a negative in front of the number. And then I divide both sides by negative 3, and this will work out nicely as a positive 11. And that is pretty much how you solve a proportion of any type. You just cross multiply, create an equation, and solve that equation. Let's try a few more. Okay, so again, I'm going to pause the video here so that way you can try these on your own. And then when you unpause the video, you should see the solutions on the board. Okay, so here's what I'm getting for both of my proportions. So again, I'm just going to cross multiply and set them equal to each other. And once again, it doesn't matter which side you put each product on. I could have put the 2x over on the right and the negative 30 over on the left. So long as you're setting them equal and you're multiplying correctly, you should get the same answer no matter what. I got x equals negative 15. The more complicated one on the right, both of these were a sum or difference. So you have to remember that when you do your cross product, that sum or difference has to be contained in parentheses. You have to have these parentheses when you set up your products. If you don't have them, you're going to get the wrong answer. And then you just have to use the distributive property to get rid of the parentheses. Here you end up having variables on both sides. I subtracted the 4c from the 7c to give me a 3c, and at that point it's a two-step. I subtracted the 7 from both sides and got negative 15, divided both sides by 3 and got negative 5. And that's pretty much it. So once again, feel free to rewind the video if necessary, and I will see you guys next time. Take care.